Pereira and I'm from RIT Engineering College, and today we are basically going to learn how to find voltage across any 2 points in a given circuit. Now, if we talk about finding out voltage across any 2 points in a given circuit, it is basically taking any one point and finding out the voltage with respect to the other point. So now if I am saying any 2 points, for example, say voltage across C and F. So across C and F. So I want to find out the voltage across these 2 points, C and F. Now practically, if we see, or practically if we want to find out the voltage, what do we do is, if we have a circuit like this, and you want to find out the voltage across this resistor and this voltage source of 5 volts, the 2 points will be here. So practically we'll take a voltmeter and connect one terminal of the voltmeter at C and the other terminal of the voltmeter at F. So in a practical circuit, if we want to find out the voltage across C and F, what we do is we will take a voltmeter or a multimeter. If it's a multimeter, we'll put it on voltmeter mode and we'll connect one of the terminal to C and the other terminal to F. Now a voltmeter has 2 terminals, as we know. It has the positive and it has the negative. So the red wire or the red terminal will be connected to C and the black wire or the black terminal of the voltmeter will be connected to F. Well, so if we want to find practically the voltage across these 2 points, one terminal of the multimeter will be connected across C and the other terminal will be connected across F. So if you want to find out the voltage VCF, the positive terminal, the first positive terminal will be connected to the first point, that is C. So your positive terminal will be connected to C and your negative terminal of the voltmeter or the multimeter will be connected to F. So once we connect both these terminals, we will find out the reading and gauge the value of the voltage across those 2 points, that is C and F. So this is how it is done practically. So basically C is connected to the positive wire and F is connected to the negative terminal. So we have 2 positive and we have negative. Now this is basically done practically, but now if we want to find out the voltage theoretically, we basically can find it out using the same KVL concept that was taught before. So if we want to find out the voltage across VCF according to KVL, which states that number of voltage sources in that loop equals to the number of voltage drop in that same loop. So we can take any loop. We can take across this loop, we can take across this loop, we can take across this loop, or we can take the voltage across this loop. No matter which loop you take, you will get the same value. Now to make it simpler, we have points A, B, C, D, E, F, G and H. So if I am considering this loop, which is the most fastest and the easiest loop, it is the voltage across C and F. So I am moving from positive and going to negative. However, the converse is also possible. You can move from negative and even go to positive. But it is across these 2 points, so via C and F. Now I can even go via this loop as well. So this will be from C to D, from D to E and E to F. In the same way, I can even go from C to B, B to G and G to F. Another way could be from C to B, B to A to H, H to G and G to F. So no matter which way you take, whether it is the long way or it is the short way, your answer will be the same, maintaining the equilibrium in the circuit. So you can take either the shortest part or you can take the longest part, you will get the same answer. So better is to take the shortest path to solve it quickly. So this is how you can find out the voltage across any 2 points in a given circuit. In the same way, if you want to find out the voltage AG, so I have 2 terminals here, A and G. Now the shortest way would be this, from A to H and H to G. We already found out the value of AG, it is 20 volts. But if the value of AG is 20 volts here, I should even get the voltage across points A to B, B to G also as 20. In the same way, from points A to B, B to C, C to F, F to G also as 20. Another loop could be A to B, B to C, C to D, D to E, E to F and F to G. This also will be 20 volts. Now what we have to remember here is, it starts at A and you have to end at G. So whichever loop it is, it has to end up at G. So this is basically how you can find out your voltage. So I have purposely taken these 2 points, that is points A and G, so that, because I already know that the voltage across A and G is 20 volts. So no matter which loop you take, your end result will go as 20 volts itself. So this is how it is done. Always remember one thing, the first terminal is taken as positive and the second terminal is taken as negative. In the same way, we can find out the voltage for AG as well. Since A is the first terminal, it is positive, and G is the second terminal, it is negative. Because whenever you consider VAG, the voltage across AG, your positive terminal will be connected to the first terminal of the multimeter, which is here. So this will be positive, and your G point, your second terminal, will be negative. Your multimeter has 2 terminals, as I said, it has a positive and it has a negative. So the positive will be first connected to A and the negative will be connected to G, and you find out the voltage across this points. So you can travel to whichever way, which we have already discussed. So this rule will never change. Now another thing, to find out the voltage across VDE. Now we have our D terminal here and we have our E terminal here. So what is the voltage across VDE? The shortest path would be via points D and E, which is 30 volts. So we already know now VDE is 30 volts. But how the voltmeter will be connected? The first terminal or the positive terminal of the voltmeter will be connected to D and the negative terminal will be connected to E. So you have your positive terminal connected to D and your negative terminal connected to E. So this also will have a positive here and a negative here. Now let us proceed further. So always remember to highlight the first terminal as positive, second terminal as negative. Positive, negative, positive, negative, positive, negative. Alright. Now once this is done, say you want to find out the voltage across VCF, our first unknown. So across VCF, my first terminal of my multimeter, which is my positive terminal, will be connected across C and my negative terminal will be connected across F, which is already done. Now the shortest path wherein I can find out the value of VCF would be from C to F. I can even find out from C to D, D to E and E to F, which will also give me the same answer, or even this, or even this. So we will first find out the voltage across VCF. Now before we go to find out the voltage across VCF, VCF have 2 components. First is your voltage drop across the 2 ohms resistor and your voltage source. So VCF is equals to the voltage drop across the 2 ohms resistor and the 5 volts voltage source. So we have V3 which is equals to 5 volts and we have 2 ohms resistor. But if we want to find out the voltage drop across this resistor, we will have to know the current that is flowing in this resistor. Now according to Ohm's law, we have V equals to I into R. R value is already given, it is 2 ohms. We don't know the voltage and the current is also unknown. So basically we need to find out the current in this 2 ohms resistor. So how can we find out the current in this 2 ohms resistor? As we already learned through Maxwell's loop current method, wherein we have 2 ways, the simultaneous equation mode and the matrix mode. So we can use Maxwell's loop current method and find out the loop currents and thereby finding out the value of current flowing in the 2 ohms resistor. So according to Maxwell's loop current method, the first step that we require is to basically highlight all the loops in the circuit. So I'll call this as loop 1, which consists of current I1. I'll call this as loop 2, and I'll call this as loop 3. This is according to Maxwell's loop current method, which we have done in the previous video. If you have any doubts related with it, you can always go back to the previous video and check how Maxwell's loop current method is done. I have even explained the direct shortcut method, wherein you can get the equation in just one step. So we will basically use that shortcut method. If you want details, you can always go back and check how you get that one-step equation. So if this is loop 1, the current flowing in this loop will be I1. If this is loop 2, the current flowing in this loop is I2. And if this is loop 3, the current flowing in this loop is I3. So if we are going to use the shortcut technique that I taught to you earlier in Maxwell's loop current method, there are 3 things we have to do. First thing is circle the loop or circle the mesh. So this is one loop, so I'll call this as loop 1. This is a second loop, so I'll call this as loop 2. And this is the third loop, so I'll call this as loop 3. So we circle the independent loops. After this, we represent loop 1 current as I1. We represent loop 2 current as I2. We represent loop 3 current as I3. After this step, we have to compulsorily assume all the directions in clockwise. Now, if you want to use the shortcut method, we have to compulsorily assume all the directions in clockwise way. So, I have I1, which is assumed in clockwise. I have I2 also assumed in clockwise, and I have I3 which is also assumed in clockwise. How to use this method, as I told, no matter, even if you know that I3 is not flowing in clockwise because of the higher magnitude of V5, which is 30 volts, although you feel and you can easily come to know that it is going to be anti-clockwise, still we have to assume it in clockwise. Otherwise, the shortcut method won't work. So once you have assumed the directions, then we basically have to put the polarities of all the voltage sources. Now, putting the polarities is also a very crucial step here. Voltage sources polarities will never change, so we can directly input the polarities of the voltage sources. Now, once your loops are drawn, your currents are named, and your directions are assumed clockwise, and the polarities of your voltage sources are designated, after that we can start our direct method. So, using KVL in loop 1. Now, as per the shortcut method, if we have loop 1, this is my loop 1 or my mesh 1. KVL states that the number of voltage sources in the loop is equals to the number of voltage drops in that same loop. So how many voltage sources I have? I have V1, I have V2. Now V1, your current that is flowing from V1 will move from positive to negative. See the loop and see my finger. It's moving from positive to negative. So what direction is this? Clockwise. Clockwise is matching with this, so this is positive. So we have plus 20. Now what about the voltage in V2? How the current is moving from the voltage in V2? From positive to negative. So it is moving in the anti-clockwise direction. Is this direction matching with my I1? No. I1 is moving in clockwise, this is moving in anti-clockwise. So the current due to V2 is moving from positive to negative, so which is anti-clockwise. So it will be plus 20 minus, and this is 5 volts, the voltage across V2 is 5 volts. Now, if we want to find out okay, 3 minutes before 5 volts has to be added in, and V2 value is equals to 5 volts. So now if we want to find out the equation in loop 1, so KVL, using KVL in loop 1. So KVL states that number of voltage sources in a loop is equal to the number of voltage drops in that same loop. So we will first check the voltage sources in this loop. So this is loop 1, which is A, B, G, H. So this is 1 to loop 1. So how many voltage sources are there? We'll keep voltage sources on one side and drops on the other side. So we are having V1 and we are having V2. So we are having 2 voltage sources. Now, the current developed due to V1 will always move from positive to negative, because current moves from positive to negative. So we'll trace that due to V1. This is V1, we have positive terminal here. So current will start from positive and go to negative in this particular loop. So see how my finger is moving? It's moving in which direction? Clockwise direction. So this clockwise direction is matching with the direction of I1. So if it is matching with the direction of I1, which is also clockwise, the value will be positive. So it will be plus 20. Now, selecting the other voltage. Again, current moves from positive to negative. So the current due to V2 will also move from positive to negative. But in which direction it is moving right now? My finger is tracing which direction? It's tracing the anti-clockwise direction. So it is moving in anti-clockwise direction, which is in opposition to the direction of I1. I1 is in clockwise, this is in anti-clockwise. So it will be 20 minus 5 volts. So 20 minus 5 volts will give us 15. So it is a very easy concept, and always remember, trace the circuit from positive to negative or negative to positive, and that way you will come to know whether the direction of I1 matches with the direction of your voltage sources. So 20 minus 5 gives us 15. Now we have to basically find out the voltage drops in this circuit. Now, how many resistors are there? We have a 5 ohms resistor in this loop 1, and we have the 3 ohm resistor in this loop 1. You have to only take with regard to loop 1. So we have 2 resistors, 5 and 3. But I1 is flowing in 5 ohms. As we see, I1 is flowing in 5 ohms, and a part of I1 is even flowing in 3 ohms. So basically I1 is flowing in 5 and 3. So we add both the resistors. 5 plus 3 will give us 8 I1. But now as we see, part of I1 is flowing in 3 ohms, but this is a junction. So this 3 ohms resistor here is not only interacting with the I1 current, it is even interacting with the I2 current. So I1 is flowing from top to bottom and I2 is flowing from bottom to top. So you have I1 coming here and you have I2 coming from the other direction. Now in the shortcut method, any current not pertaining to that loop, should be taken in a negative sign. So if I am talking about loop 1, my I1 will always be positive. If I am talking about loop 2, with regard to loop 2, my I2 will always be positive. If I am taking the loop 3 equation, in the same way, my I3 will always be positive, but others will be negative. So any other current which is not pertaining to that loop will be taken as a minus sign. So in the shortcut method, you can just directly write a minus sign here. Now I2 is flowing in which resistor? With respect to loop 1, it's only flowing to the 3 ohms resistor. So it is 3 I2. So this is the drop across your resistors. Drop is nothing but your voltage drop, and Ohm's law states that V equals to I into R. So we have a R and we have a I. So I into R will give us V. Again, I into R gives us V. So we found out the drops. So now this is my equation 1. So I just got it in one step. So I'll just write the loop 2 equation quickly. And the loop 3, which is minus 35 equals to minus 2 I2 plus 10 I3, which is my equation. The systematic breakup of this is basically already explained to you in the previous episode. But just going briefly, now if I am applying the KVL in loop 2, how many voltage sources are there? 5 volts, 5 volts and 5 volts. Again, current moves from positive to negative if I am taking this voltage source of V2. What is the direction? Clockwise. Matching with this, so it is positive. What about V4? It flows from positive to negative. Finger is still moving in the clockwise direction, again matches this I2. What about this voltage source? 5 volts. Current moves from positive to negative. Again my finger is moving in the clockwise direction, so it is again positive. So it is plus 5 plus 5 plus 5, which gives us 50, equals to number of voltage drops in this loop 2. How many resistors we have? We have 3 ohms, we have 4 ohms and we have 2 ohms. Now I2 is basically flowing in the 3 ohms, it is flowing in the 4 ohms and it is even flowing in the 2 ohms. So I add all these resistors. So 3 plus 4 plus 2 gives us basically 9 I2. As it is pertaining, I am talking with regard to loop 2, and loop 2 is pertaining to I2. So I2 will always be positive, the others will be negative. So I got my 9 I2. Now in the 3 ohm resistor, this is the junction. So the 3 ohm resistor is basically interacting not only with I2, but it is even reacting with I1. So the current in the 3 ohm resistor is a combination of I1 and I2. I1 will be from top to down and I2 will be from down to top. So anything other than loop 2, any other current other than loop 2 will be be taken as minus. So we have minus 3 I1, and in the same way we have minus 2 I3. So whatever other currents are there will be taken as minus. Now coming to loop 3. Now in loop 3, how many voltage sources are there? We have 2 voltage sources, one of 5 volts and one of 30 volts. As we all know, current moves from positive to negative. So I consider this positive to negative. What is the direction? Clockwise or anti-clockwise? Definitely it is moving in anti-clockwise, which is in opposition. So this is minus. What about this? This is also moving from positive to negative, which is anti-clockwise. So again it is minus 30. So minus 5 minus 30 will give us minus 35. So minus 35 equals to, now we have to find the drops. Now we all know I3 is flowing in the 8 ohms and it is even flowing in the 2 ohms. So I add both this, 8, 9, 10. So 10 I3. Now any other current from the other loops which is interacting with that resistor pertaining to the loop that we want will be taken as minus. So 2 ohms is even interacting with the I2 current which is in loop 2. So it is taken as minus 2 I2, which is written here. So in this way we can avoid all the tedious steps and just write it in equation 1, 2 and 3 effectively, thereby saving time. So you can get your equations in just one step. Now once you get these equations, you can use your calculator, which is either Casio FX 991 ES or ES Plus, and find out the values of I1, I2 and I3 using simultaneous equation mode in your calc. So once you input these values in your calculator, you will get the values of I1 as 2.56 amps, I2 you will get as 1.82 amps, and I3 you will get as minus 3.14 amps. Now if you see here, you got all your currents. If your current is in positive, if your current comes in positive, basically whatever direction you have assumed is correct. So I got plus 2.56 here. So whatever direction I assume for I1 is correct. Now keeping the value, putting the value in the diagram. So I1 equals to 2.56 amps. What about I2? I2 is also equals to 1.82 amps. And the direction is the same that we assume. But the value of I3 is equals to minus 3.14 amps. Now if we get a negative value, that means whatever direction that we have assumed for I3 is wrong. So if I have assumed the direction for I3 in clockwise, then actually the direction is not clockwise, it is in anti-clockwise. So I change the direction to anti-clockwise. Once I change the direction to anti-clockwise, this minus 3.14 will become plus. So in your next step, you have to again write down the currents. I1 equals to 2.56, I2 equals to 1.82 and I3 equals to 3.14 since we have changed the direction in the diagram. So you have to draw this diagram again and change the direction of I3. So this will be your updated diagram with all your loop currents. So I will input the current of I3. which is equals to 3.14 amps. So now I got I1, I got I2 and I got I3. Now moving on further to find out what is the value of VCF. But before we go to this, we have to assign the polarities of all the resistors. Now when your current basically moves from positive to negative, okay, the first terminal that it touches becomes positive and the second terminal it touches becomes negative as that of a resistor. That means, say in I1 loop. In I1 loop, the direction of current I1 will be this as per the loop. So if this is I1 and this is my direction, okay, the first terminal that my current touches of any resistor becomes positive and the second terminal becomes negative. So this is how the polarity is assigned. Then in I2, the first terminal it touches, take a green chalk. The first terminal it touches becomes positive and the second terminal it touches becomes negative. In the same way for loop 3. In the same way for loop 3. Now here the direction is in anti-clockwise. So I will get an anti-clockwise direction in this loop. So this will be my I3. So the first terminal it touches becomes positive. The second terminal it touches becomes negative. Now this is with regard to loop 1. But in these loops we have two junctions and the two junctions are caused by the 3 ohm resistor and the 2 ohm resistor. Now there are two currents flowing in this resistor. Part of that current is I1 and the other is I2. So I1 and I2 is flowing in this 3 ohms resistor. What about the 2 ohms? You have I2 and you have I3. Now, how we will come to know the directions in this resistor? It is pretty simple. If this is your I1 direction, it is flowing from top to down. And what about I2? I2 is flowing from down to top. So it will be a combination of I1 minus I2, because I1 is flowing from top to down and I2 is flowing from down to top. So it will be I1 minus I2. But what will be the effective direction? This can be found out on which is greater. I1 is greater, I2 is greater, definitely I1 is greater. So the effective direction will be taken from top to down. So you just have to see which of the currents is greater, that will give you your direction. Since I1 is greater, it will be from top to down. So we have 2.56 minus 1.82, which will give us, so the current here will be 0.74 amps. So the current here will give us 0.74 amps. In the same way, you can even find out the current flowing in the 2 ohm resistor. Now in the 2 ohm resistor you have I2 also flowing in it and you have even I3 flowing in it. Again, the direction is determined by the highest value of current. Which is the highest value of current, I2 or I3? Definitely it will be I3, because 3.14 is greater than 1.82. So you can directly put your direction here. So it will flow from top to down. Now, what will be the value? You have I2 flowing in this direction and you have even I3 flowing in this direction. So you have I2 and I3. So the effective current flowing in the 2 ohms resistor will be I2 plus I3. So here it is additive because both the currents are flowing into the 2 ohms resistor. So 1.82 plus 3.14 will give us 4.96 amps. Now again we will put the polarities. This is the effective direction. The first terminal the current touches becomes positive, and the second terminal it touches becomes negative. Now again here the first terminal the current touches becomes positive, and the second terminal it touches becomes negative, since I got the direction. So positive, negative. Now once you found the current through each and every resistor and assigned its corresponding polarities, we can move on to the next step, that is to find out the voltage across any 2 points. So say we want to find out the voltage across VCF, so across point C and F. Now as I told you, you can either start from C and go to F directly. So this is one loop. You can even take these points C to D, D to E and E to F. So you can either go in this loop as well. You can even take this loop as well, or you can take this loop as well. So let's take the shortest route, which is via points C and F directly. So via points C to F, which is the most shortest route. So you're going to avoid all your tedious calculations by shortening your steps. So across points C to F. Now always remember, the first terminal of your multimeter will be connected to your positive terminal, and the second terminal of your multimeter will be connected to your negative terminal. So your red terminal will be connected here and your black terminal will be connected here. So C will always be positive by default and F will always be negative by default. So the potential at C is positive and the potential of F is negative, because the terminal of your multimeter is positive here. So if C is positive and F is negative. Now we are moving from points C to F. So you can either start from C and go to F, or you can start from F and go to C. So we will consider the first case. Okay, we will consider from starting at C and then going to F. So this will be my start and this will be my stop. So starting from C, the first terminal it comes in contact is the first terminal of the resistor. What is the first terminal of the resistor? Positive. So my sign polarity is positive. Now I have to find out the voltage across this. Voltage across this will be what? According to Ohm's law, we have V equals to I into R. So I is what? 4.96. What is R? 2 ohms. So 4.96 into 2 ohms. So 4.96 into 2 ohms. Then again, the first terminal of the voltage source. Now the first terminal of the voltage source is a negative. Again, multiply your positive with the negative. So with reference to C, we have a positive. So positive into negative will give us negative. Negative what? Negative 5 volts. Now voltage source is 5 volts. So we already have the voltage. We don't need to use any other Ohm's law or any other equation, because voltage will give us the direct voltage value, which is 5. So we have minus 5. So substituting this, we get the value as 4.92 volts. So now we basically move from C to F. In the same way, we can even start from F and even go to C. The value will come the same. So let's check this, moving from F to C. Now F is what? Negative. Okay, F is negative. Now this will be your start point and this will be your stop point or your end point. So if this is your start point and if F is negative, so we are moving from F. So the first terminal it comes in contact is the 5 volts voltage source. What is the polarity? Positive. Again, multiply both. Negative into positive, negative. That's why you got -5. Then again, moving on top. The first terminal it comes in contact is negative. Again, negative into negative, positive. So we will get the same value. So either you can start from C and go to F, or you can start from F and go to C. Only the only point of consideration which you have to take into account is the polarity of the first terminal. Always remember, since the first terminal of your multimeter is positive, your first terminal will be connected across C, which is your positive terminal, and your second terminal will be negative. So you have to remember this, that your first terminal is your positive and your second is your negative. No matter which side you start, you may start from C and end up at F, or you can start at F and end up to C. But remember the polarities. The polarity will not change. So the first point will be positive, the second point will be negative. So now we found out the voltage across VCF, which is equals to 4.92 volts. But now this is across C and F. So wire points directly C and F. Now you can even go via points C to D, D to E and E to F. You can even go via points C to B, B to G and G to F. So you can either go in this loop, or you can go in this loop, or you can go directly. Your answer should come same. So we will just prove whether we will get the same value or not, to check the consistency of this theory. So although you got the value of VCF, which is 4.92, we will go for the second method, or we will go for the second loop. Now when we go for the second loop, we should get also the same value. So for the first, we went via point C to F, wherein we got the value. Now we will go via points C to D. Go via points C to D, D to E and E to F. So even if we go via these points, we should get the same voltage that is 4.92. Here also, if you go via these points, we should get the same voltage. Even if we go via these points, we should get the same voltage. So we will just check the consistency of this technique. Now across C and F, this will always remain same. The positive terminal of the multimeter will be connected across C, and the negative terminal of the multimeter will be connected across F. Now going via points C to D, D to E and E to F. So if I am moving from C to F, as I told you, you can even move from F to C. So now I am basically moving from C to F, that is I am starting at C and ending at F via point C, D, E, F. So starting at C. The first terminal I meet is the 8 ohms resistor, and it is a minus terminal. Again, positive into negative, negative. So I have to multiply. Clear? So positive into negative, negative. Find out the voltage drop. What is the current flowing in the 8 ohm resistor? It is I3, which is 3.14 into 8. Now again moving from C to D and now from D to E. Now when it is moving from D to E, the first terminal it touches is a positive terminal of your voltage source. So positive into positive, positive. So it is 30 volts. So I get a value 4.88 volts, which is nearly the same as 4.92. So again, the consistency of this is proved. If we take a decimal shift, it will become 4.9, which is nearly equals to 4.9 of the previous one. So no matter which points you take, you will get the same answer. Let's have another check. Just to be sure. And now instead of taking wire points C, D, D, E and E, F, I will take wire points C, B, B, G and G, F. So this also should give me the same answer if this technique proves right. So I should get the same answer. So let's check whether the same answer is achievable. From C to B, from B to G, and then from G to F. So now I am starting from C and ending to F via point C, B, B, G and G, F. So I am starting from C and going to F. So the first terminal it touches is a positive terminal of the voltage source. Positive into positive, positive. What is the voltage source value? 5 volts. Then for the resistor of 4 ohms, first terminal of the resistor is negative. So negative into positive, negative. Current is what? I2, that is 1.82 into 4. Then again, the first terminal of the 3 ohms is positive. Positive into positive, positive. What is the value of current flowing in this resistor? 0.74. So 0.74 into 3. Then after this, the first terminal of the voltage source is positive. Positive into positive, positive. So plus 5. Then any voltage source or current source? No. So after that it moves directly to F. So what is the value of this? So we get the value as 4.94 volts, which is again equivalent to the values what you obtained. So this proves that no matter which loop we take, either we can take the CF loop directly, or you can take the C, D, E, F loop, or you can take this loop, or even if you take this loop, you will get the same value of voltage. So even if you take C to B, B to A, A to H, H to G and G to F, also you will get the same value, that is equals to 4.9 volts roughly. So you will get 4.9 volts no matter which loop you take. So this proves that any loop is possible, but what has to be considered is the shortest way. So obviously, if I want to complete the problem in a given amount of time, I can take my shortest loop, which is C to F, or C, B, D to E, E to F. Because I have only one resistor and a voltage source. In the same way, I have only one resistor and a voltage source here. Whereas for the others, I have more than 2. So the shortest would be basically these 2 loops. So the more shorter it is, the more faster you can solve it. VCF via point C, B, G and F will be 4.94. Via point C, D, E, F is 4.88, which is nearly equal to 4.9 volts. And via points C to F is also 4.92 volts. So basically, no matter which loop we take, either if we go for CF, or we go for C to D, D to E and E to F, or we go for this loop, or we go for this loop, you will get the same value of voltage. So no matter which points or which wire points we take, the value of the voltage will always remain the same. So with this technique, what we have developed, we can say that no matter which points we take, the final outcome will be the same voltage. You can even take across C to B, B to A to H, H to G and G to F. Still you will get 4.9 volts only. So you can just try it out with this loop as well. So no matter if you take this loop, you take this loop, you take this loop or you take this loop, you will get the same answer. But obviously I would always select the shortest loop. So either this one or this one, because it only involves two components. So I can find out my answer more quickly as compared to this, because this loop contains more than two components. It has two resistors and two voltage sources. So my length and time for completing the problem also becomes more, because I have more values to cater to. So obviously I will take the shortest wire directions or wire points, which is directly either C to F or C to D, E to E, E to F, because I have only two components. So I will take the shortest route. But this is basically for you to understand that no matter which wire point you take or which loop you take, either this or this, you will get the same answer, because it's just the voltage across those 2 points, and voltage across any 2 points is the same. Now, since we got the value of VCF, I'll rub these steps, since we already proved the point. And now I will go to find out the voltage across VAG. VCF is already found out. Now the voltage across VAG. Now, as I told you, the first terminal is connected to the positive of the multimeter, that's why it's positive, and the second terminal is negative. So the first terminal is connected to the positive of the multimeter, that is A, and the second terminal is connected to the negative terminal of the multimeter. Now I can go wire points which is the most shortest route, via points A to H and H to G. So via points A to H and H to G. And I'm assuming my way is from A to G. So A is my start point and G is my end point or my stop point. So I'm moving from A and going to G. Now when I'm moving from A to H and H to G, what is coming in the way? My 20 volts supply. So A is positive. So I'm moving from A. The first terminal it touches is the positive terminal of the V1 voltage source. So again, positive into positive, positive. What is the voltage supply? 20 volts. After that, any resistor voltage is there? No. So it directly ended. So what is my final answer? Plus 20 volts. But as I told you, it is not necessary that you will only get the answer across these points. You can even get the answer across this loop. You can even get the answer across this loop, or you can get the answer across this loop. So no matter which loop you take, you will get the same answer. So we'll just try with a different loop and see whether we are going to get the same 20 volts. Now the reason why I have taken this easy one is because we are confirmed that the voltage here cannot exceed or go below 20 volts. So the value of no matter which loop we take should yield us a consistent value of 20 volts. So now I will try other points and I will see whether it gives me 20 volts or not. So if it doesn't give me 20 volts, that means I know the technique what we are using is wrong. But if it gives me 20 volts, that means the technique what we are using holds good and is correct. So now I will try to find out the voltage across VAG across points. So we go via points. A to B and B to G. Now, as I told you, if you want to find out the voltage across any 2 points, you can either take this loop, you can take this loop, you can take this loop, or you can take this loop. Only what you have to remember is you have to start from one point and end to the other point, and highlight your positive and negative terminals of your multimeter. So now we will take the loop from A to B and B to G. So it is moving from A, going to B and going to G. So this is my second loop. Now even in the second loop, I should yield the same result of 20 volts. So let's see if we are getting the same 20 volts result. Now again, positive terminal of the multimeter is connected to A, negative terminal of the multimeter is connected to G. Again it moves from A to G. So A is positive. First terminal it comes in contact is positive. Positive into positive, positive. What is the voltage in this? It will be I1 into 5. I1 is 2.56 into 5. Then we have, once it moves here, again the first terminal it comes in contact with is a positive. Positive to positive, positive. Which is 0.74 into 3. Then again the other terminal it comes in contact with after the 3 ohm resistor is the positive terminal, first positive terminal of V2. So again positive into positive, positive, which is 5. So this is equals to 20.02 volts, which is nearly equal to 20 volts. So this 20 volts is matching with this. So again, I am confirmed of this technique consistency. So the consistency of this technique is again proved. Now how I took points A to B, B to G, I'll even try taking points A to B, B to C, C to F and F to G. So now I will take another loop and again check for the consistency of this technique. So now I take via points A to B, B to C, C to F and F to G. So even if I take via these points, I should yield the same result. Again, positive terminal of the multimeter is connected to the first terminal A and the negative terminal is connected to the second terminal G. And I am moving from positive to negative. That means I am moving from A to G. As I told you, you can even move from negative to positive. It makes no difference. You will get the same answer. Only that you have to take care of the polarities. So moving from A to G. As I told you, first terminal of the 5 ohm resistor is the positive terminal. Multiply both the polarities. So positive into positive is positive, which will give me 2.56, which is the current flowing in the 5 ohm resistor, into the resistance value, which will give me the voltage. Then I have another terminal which is from in B to C, which is positive in nature. So positive into positive is positive. So it will give me I2 into 4. So 1.82 into 4. And I have, after completing this, it goes to the negative terminal, which is my first terminal of V4. So positive into negative gives me negative, which is 5 volts. Now, from C to F, now it is moving from C. So the first terminal the current touches, it is a positive terminal here. So positive into positive gives me positive. The current is how much? 4.96 into 2. So I have 4.96 into 2. So I have 4.96 into 2. So after my 2 ohms resistor, I have my 5 volts. Now the first terminal of the 5 volts is negative. Positive into negative gives me negative. So minus 5. Plus into minus gives me negative. Positive into negative, negative. So this will give me a value of exactly 20 volts. So if you check this, you are getting basically 20 volts. So I am getting 20 volts across VAG via points A, B, C, F and G. So no matter which wire points you take, your answer will always be consistent. You will get the same answer no matter which point you take. So in the same way, how I found out for this loop, which is equals to 20 volts, I can even find out from wire points A to B, B to C, C to D, D to E, E to F and F to G. So even if you do via these points, you will yield the same result, that is 20 volts. So in this way, I can find out the value of voltage across any 2 points. So no matter if it is points VAG, I can take either this loop, I can take either this loop, I can take either this loop, or I can take either this loop. I will yield the same result, that is 20 volts. Now we have found out the voltage across VCF, VAG. Now we will find out the voltage across VB. So I will drop this. This is the shortest way. These steps I have done just to prove you the consistency of the technique that I just told you. Kindly note that this technique is not given in any book. I have developed it myself. Now, we have to find out the voltage across VB. Again, the first terminal of your multimeter is connected to the positive and the second terminal is connected to the negative. And I am moving from D to E. So, D to E. Now, my shortest route would definitely be this, and my other routes would be this, this, or this. But no matter which route I take, I will yield the same result. So first we will start with the shortest route. So wire points D to E. So wire points D to E. Now the first terminal, as I told you, is the positive and the second is the negative. So if I'm considering my first terminal, I'm moving from D to E. So the first terminal it touches is the 30 volts voltage supply, that is V5. The first terminal is a positive. Again, multiply both the terminals, the first with the first. So positive into positive, positive. So plus 30 volts. Any other resistor voltage source? No. So VDE is equals to 30 volts. Now again I will check the consistency of this technique. Now I have taken across directly points D and E. Now I will take wire points. So I will take basically this loop. So I will take wire points D to C, C to F, and F to E, starting from D. The first terminal it touches is a positive terminal of my 8 ohms resistor. So positive into positive, positive. What is the value of current? 3.14 into 8. Then again, the first terminal of this resistor is what? Positive. Positive into positive, positive. What is the current flowing in this resistor? 4.96. So 4.96 into 2. Then, what is the first terminal of this voltage source? Negative. Again, negative into positive, negative. What is the value? 5. So I get a value of 30.04 volts. So I get 30.04 volts. So this is across D to C, C to F, and F to E. So no matter if you take it across this, or across this, I will get the same value. Now we will just again check the consistency, and it will be a practice for us. We will take wire points D to C, C to B, B to G, G to F, and F to E. So basically it is this loop. So I am taking the long route. So it is D to C, C to B, B to G, G to F, and F to E, and F to E. So now my VDE will be equal to, obviously positive terminal is connected to D of the multimeter and the negative terminal is connected to E. So taking this long loop, first terminal that it comes across with is your 8 ohms. The first terminal of your 8 ohms is positive. So positive into positive, positive. What is the current? 3.14 into 8. Then what is the first terminal of V4? Positive. Again, multiply both the terminals. Positive into positive, positive. Then again, first terminal of the 4 ohms resistor is negative. Again, multiply both the terminals. So positive into negative is negative. So negative. What is the current? 1.82 into 4. So I have 1.82 into 4. Then what is the first terminal of this 3 ohm resistor? Positive. Since I am coming from this side, so this is positive. Positive into positive, positive. So 0.74 into 3. 0.74 into 3. Then again, the first terminal is what? Positive. Positive into positive, positive. So plus 5 volts. So my final value, what I get, is equals to 30.04 volts. Again, the 30.04 volts is matching with this and it is matching with this. So in this way, no matter which loop you take, you will get the same result. Even if you take now for loop BC, CB, BA, AH, HG, GF and FE, also you will get the same value, that is 30.04 volts. Now this is basically taking your start point from D and moving to E. As I told you, you can even move from E to D. So I'll just give one quick review on how you can move from D to E. Now this is basically if you are moving from D to E. But as I told you, you can even move from E to D. But the sign conventions will not change. So if I have D and E. So this is my start and this is my stop. Now I'll start from E and go to D. Now if I'm starting from E, the first terminal it comes in contact with, see if I'm starting from here, this is taken as my first terminal because it's moving from E and going to D. It's moving from E and going to D. So the first terminal it comes in contact is the V2. But V2 first terminal right now becomes what? Minus. So minus into minus, plus. So I get plus 5. Then I have the 3 ohms resistor. The first terminal of the 3 ohms resistor is negative. Negative into negative, positive. So positive. 0.74 into 3. Then again, the first terminal it comes in contact with is positive. So positive into negative is negative. So I get the negative sign, which is 4 into 1.82. So 1.82 into 4 will give me the voltage drop. Then for V4, the first terminal it comes in contact with is a negative. So negative into negative, again multiply both the terminals. But here remember, for D it was positive. Here you have to multiply the negative terminal. So negative into negative, positive. So plus 5 volts. Then after this it moves to the 8 ohms resistor. First terminal of the 8 ohms resistor is negative in nature. So negative into negative, positive. So 3.14 into 8, which will again give me the same result, that is 30.04 volts. Now one more thing you have to remember is, if your VAG is equals to 20 volts, then my VGA will be equal to minus 20 volts. In the same way, if my VDE is equals to 30 volts, then my VED will be equal to minus 30 volts. Now how does this come into play? Now if I consider my multimeter or my voltmeter and I connect my positive terminal here and my negative terminal here, obviously this is positive and this is negative. So I'll get plus 30 volts. But if I interchange my terminals and connect my positive here and negative here, then what will happen? On my multimeter display or on my voltmeter, I will get minus 30 volts. So I'll get minus 30 volts because this is my positive terminal and this is my negative terminal of my multimeter. Initially this was my positive and this is my negative, which was plus 30. But if I change it, it will become minus 30 because of the polarity which is here. So I'll get minus 30 volts. So in other words, if I'm changing my polarity, even the change of terminals will create the same effect. So if my VDE equals to 30 volts, so obviously my VED will be equal to minus 30 volts. Why it will be equal to minus 30 volts? Because right now I am considering E as positive, D as negative, because I am connecting the positive terminal to E and the negative terminal to D. So if this is positive here, positive into negative is negative. So that's why minus 30 volts. So always remember, if your VAG equals to 20 volts, so your VGA will be equal to minus 20 volts. So if you change your terminals, your voltage polarities also will change. It is the same thing as stating your G terminal as positive and A as negative. So if you take GA, so I have my G here and I have my A here. So if I am taking the first terminal as G, that means my positive terminal of my multimeter is connected here. This is my positive terminal and my negative terminal is connected here. But the first terminal here is negative. So if I am moving from G to A, this is positive right now. Positive into negative, negative. So I will get minus 20 volts displayed on the terminal of the multimeter. So that's why it comes minus 20 volts. Always remember and keep this in mind. Always refer to the multimeter side of the value. So now I'll just run this long cut method. So I can easily find out the voltages through any points from this technique. Now I know the value of VDE. VDE is 30 volts, which I directly found out directly across points E and E, which is 30 volts. Now say I want to find out the voltage across VED. Now, if I want to find out the voltage across points VED, as I told you, the shortest path would be this. So, via points E to E. Now, to use this technique, I told you the first terminal of the multimeter, or your positive terminal of your multimeter is connected to E and your negative terminal of your multimeter is connected to D. So D will be negative. So applying the same logic here, E will be positive right now and D will be negative. So if I am starting from E and going to so the first terminal it touches is the negative terminal of V5. So this is negative. So positive into negative, negative. So I get minus 30 volts. So if you see this, if my VDE is plus 30 volts, then obviously my VED will be minus 30 volts. It will have the same magnitude, but its directions will be reversed. So, if this is positive, this will be negative. If this is negative, this will be positive. So, only difference is that its polarities will be reversed. So, this is what happens. So, in the same way, I have VAG. If my VAG equals to plus 20 volts, then obviously my VGA will be minus 20 volts. This revolves under a simple concept that if I am considering my point VDE, so positive terminal of the multimeter is here and my negative terminal of my multimeter is here. So if I'm having my multimeter, say this is my positive terminal and this is my negative terminal. So if I connect my multimeter across points VD, the first terminal of the multimeter will go on this point, that is my D point, and the second terminal, that is my negative terminal, will go across my E point. So if I am connecting my multimeter across this, in my display I will get it as plus 30 volts, because this is plus and this is negative, so I am getting plus 30 volts. But if I am reversing the terminals of my multimeter, that means right now if the positive is connected to E and the negative is connected to D, since this is positively charged and this is negatively charged, I will get a value of minus 30 volts. So if I am interchanging my multimeter terminals, I will get minus 30 volts. So this is the same thing what is done here. I interchange the terminals. So I want to find out the voltage across VED. So the positive of my multimeter is here and the negative is here. But since this is negative in nature, which is near my positive, it will give me minus 30 volts. So if you find out the value of VD is 30 volts, then obviously VED will give you minus 30 volts. If you find out the value of VAG, which is 20 volts, so definitely VGA will give you minus 20 volts. If you find out the value of VCF, which is 4.92 volts, which was our first voltage that we have to find out across terminals C and F, we got 4.92. So that means VFC is minus 4.92. So when you are interchanging the terminals, the magnitudes will remain same, only the polarities will change. So your positive will become negative and negative will become positive. So in the same way, how we got VD equals to plus 30 volts, VED equals to minus 30 volts. If VAG equals to 20 volts, then VGA will be equal to minus 20 volts. And in the same way, how we got VCF equals to 4.92 volts, my VFC will be equal to minus 4.92 volts. So what we have to remember here is the magnitudes remain the same, it's only that the polarities get reversed. So with this, we basically learn how to find out the voltage across any 2 points in a given circuit. Now say for example, if I want to find the voltage across this resistor. If I want to find out the voltage across this resistor, it will be what? V equals to I into R. But I can even find the voltage across this, which will give me the same, the voltage across this, which will give me the same, and the voltage across this, which will also give me the same. So it is across these 2 points. So across these 2 points, this will give me the same voltage, this will give me the same voltage, or this will give me the same voltage. So with this, we can find out the voltage across any 2 points in a given circuit.